Hello everybody, welcome to this webinar. My name is Roberto Cossu from the European Space Agency Business Applications, and I am here today with Beatrice Barresi, my colleague, and Grika Milczynski from Sentinel Hub. So if you are attending this webinar, you know most likely that the ESA Business Applications are partnered with Sentinel Hub to offer your business 1 year free and easy access to a wide range of Earth observation data. So the purpose of this webinar is first of all to introduce high level what ESA Business Applications can do for you, how we can support you, and then how Earth observation data can enhance your business solutions. In the second part of this webinar, Grika will present how to use the free data provided by Sentinel Hub. So just some recommendations for this webinar. Please keep always your webcam and microphones switched off. And in case of question, you can type them anytime during the webinar in the chat tool function. And then we will address them at the end of this webinar. Another point, this webinar will be recorded and we'll make it available on our ESA Business Applications website. So let's start with ESA Business Applications and let's see how we can support you and how Earth observation data can help your business. So also because the increasing number of operational satellites, it's nowadays possible to address a wide range of operational and commercial applications, taking benefits from space. These include a wide range of thematic domains from aviation, drones, energy, agriculture, infrastructure monitoring, smart cities, tourism, maritime offshore, and so on. So really a wide range of domains can benefit from space. Not only from Earth observation, but also from satellite navigation, satellite communications, and human space flights. So what is ESA Business Applications and what we can do for you? ESA Business Applications is a European funding program. We have in our wallet approximately 195 million for funding. And we already invested a lot. We have invested 190 million in over 500 European companies. So this is, I think they are excellent number. Now the opportunity is for you. How can we support you? Well, first of all, with funding, it is important to say that there are zero equity funding. Technical and commercial guidance, because we are ESA, because we have links with other colleagues in the other technical department and directorate of ESA. We can provide you with the access to our network and partners. And last but not least, you can use the ESA branding from credibility. This means that usually a lot of time we have seen in the past that being supported by ESA can open the door not only to new customers, so you can more easily sell your product to new customers, but also for obtaining other funding, maybe from private investors. So also this point is really important. So how can you benefit from space? I mentioned before there are different kinds of satellites that can improve your business, starting from satellite navigation, satellite communication, and Earth observation. Today we will focus mainly on Earth observation because of the topic of this webinar, and you can easily imagine that what can come from Earth observation are basically digital mapping, global coverage, high-resolution imagery, or weather forecast. So let's go a little bit more in depth of what Earth observation can do and which is the information that can be extracted from Earth observation data. Let's start with land monitoring. So in this case, let's think, for example, to forestry. And Earth observation can provide you indication on clear cut and partial cut of the forest, in classification of the forest type, in estimating biomass or detecting forest fires. If we go to agriculture and precision farming, which is one of the more obvious applications of Earth observation, in this case you can monitor not only the kind of crops on the ground, but also monitoring the crop conditions and the soil properties. So this can be used to help to assess the land use, to predict the harvest, to monitor seasonal changes, and to assist in implementing policies for sustainable development. In general, let's say, Earth observation can be used to characterize vegetation. So you can extract an extensive range of parameters that characterize the vegetation and usually the health of the vegetation, like NDVI and FAMR. Also, if you want to monitor snow and ice, Earth observation can provide you some useful information. For example, the kind, the classification of snow and ice, the sea ice and ice thickness as well. River and lakes, you can monitor the water level in the different basins, like river and lakes, or you can monitor an extensive range of parameters, like, for example, chlorophyll in the water bodies. Let's go to the maritime and marine area. In this case, Earth observation can be used, for example, for monitoring and detecting ships and their location. Usually this is done with satellites, but they can see also through clouds and daytime and nighttime. So this is an important information. The same satellites can be used to monitor oil pollution. If we go instead in the passive optical satellites, this can be used for marine and coastal monitoring. So for example, to detect and to monitor built-up areas, or coastal erosion, or parameters of the water like sea surface temperature, or geophysical parameters of the water like phytoplankton biomass. Earth observation can be used also for emergency management. Obviously, extreme weather events, flood monitoring, something that I think is really useful in also in commercial application is the monitor of critical infrastructure, and this can be easily done monitoring the surface deformation, so to provide early warning. Other applications include security, like maritime surveillance, border control, climate change, and atmospheric monitoring, including greenhouse gases, ozone, aerosols in urban areas, for example, but not only. So just one example of a project that recently was concluded quite recently, and is the EARTH project by Resatec Ltd, a company in UK, that in a project funded by ESA Business Applications, they developed a suite of services for detecting, monitoring, and predicting water infrastructure failures and pipeline leakage signals. So their customers were water utilities with pipelines, usually also in rural areas, so not always easy to be monitored. And the idea of this company was to use Earth observation mainly, and mainly two products extracted by Earth observation. One is terrain motion, because you can understand that the motions in the terrain can bring to failure in the pipeline, and also other kinds of Earth observation data for detecting and estimate the vegetation, because obviously vegetation can, with trees, for example, with their roots, can break the pipelines. What is important here is that these are quite, I would say in general, classic products that can quite easily sometimes extracted by Earth observation data. What is important that usually is better for many applications if these data are integrated also with other information. For example, in this project, they integrated the Earth observation information with data like historic burst, leak event data associated with the different attributes of the pipelines. So each individual pipe segment can be modeled, and with the Earth observation data extracted before, you can have somehow an index of the pipeline failure risk. So this is just an example of simple information that is integrated in a more complex way to address the needs of the customers. And you can find the information on this project in the web link that you see here at the bottom of the slide. So this concludes my part of the presentation, and I will give the floor to Greka for the part of Sentinel Hub.
Hello to everybody. So my name is Grega Neczyński. I'm a CEO of Synergize. Can just somebody confirm that you see my screen so that I can continue?
Yes, you can.
Okay, very good. So hello to everyone. Now I would like to present to you some of the features of the Sentinel Hub platform. I guess that some of you have heard about it already, but for those who not, I'll go into some basics, but then I'll go into a bit more detailed stuff for the integration, which is what you are probably most interested in. So as Roberto already nicely presented, there is really a lot of information available out there and available for free. That is, I think, a significant change over the past years, few years ago, when basically each satellite image that we wanted to work with was so expensive that we have just a couple of them. Now there's so much of data available that it's difficult to really handle, and there is much more coming. And because the amount of data is changing, we also need to change the methods how we do it, because how we worked previously is more or less that we manually downloaded the scene from some portal, and then we got these bands, and then we did some composites and we tiled them, and finally we had an application. So this doesn't work anymore. This is how we did it also in the past, because we are developing GIS applications as well. But we realized that the amount of data is simply too large to work in such a way. And so this is how we came up with the idea of the Sentinel Hub, which is basically a set of web services which hide the complexity of all these downloading, storing, processing, Earth observation, remote sensing things, behind a set of OGC compliant and proprietary APIs, which can be easily integrated in either web or mobile application, desktop application, either or used in the scripting or machine learning or whatever. Basically, the idea is to make it easier for you, and I would say that the vast majority of our users are developers, are application developers, to create applications on top of it, not to bother with the basic pixel shuffling, as we call it, because that doesn't bring too much of added value to the users. And probably the most well-known application based on Sentinel Hub services is our own Sentinel Playground, which is a sort of Google Maps. We really wanted to make it easy to use and simple, and basically it allows you to go to any place in the world and see the data in natural color, or you can use it through a different lens, for example, vegetation index or moisture index or whatever. So all of the standard remote sensing products. And you can also go back in time, because we know that the Sentinel data are being revisited every week or so. So it's really useful to have this multi-temporal approach. By the way, below you see the address of the application. So for those who are not familiar with it, I would recommend you go and look at it, because I think it nicely demonstrates the functionality. And you can even go a bit further, and you can do your own combination of bands by simply saying, I want to map band 12 to red channel, and band 11 to green, and band 4 to blue. And you create your own composites based on what you would actually like to see. Because we know that just having a true color image doesn't bring enough of added value. We want to use all the information that are available, and for different purposes we need different combinations. For vegetation we need near infrared and red, for example. For moisture some other, and so on and so on. And now what is important to note is that the Sentinel Playground application is a very simple web client based on Leaflet and React technology, which facilitates the Sentinel Hub web services. In this case, web mapping service and web feature service for the dates, and web coverage service for the downloading of the data. So it's really, it's nothing more than anyone can create. Decision tree, that's a typical result of a scientific paper on the Earth observation, and you can then simply port this decision tree into the JavaScript, and you can copy paste it here in the EO browser window, and you have it instantly visualized as well, and so that you can see how good it works. And what you can also do is, because this works globally, everywhere where the Sentinel data are available, you can go there and you can test it there as well, and you see that in this case, Holstein doesn't work as good because probably it was fitted for some other purposes. And I think that's an important point, is that the tool allows you to prototype your own methods in a very efficient manner, cost efficient and time efficient, because you can simply you can copy paste this in either the configuration utility or the application itself, and then you see how it works, and you can instantly change it and see again the result, and it works it works everywhere. It works on a global level. I think so. This global level is something that I will repeat a couple of times more, because what we believe is that if you want to make a really sustainable application, the business case application, you need to target the whole world, or at least larger regions. Having the application only available in one country is maybe good enough for prototyping, but there will never be enough users to support this long term. So you need to scale it, and it's very easy to do if you are connected to Sentinel Hub web services, because you don't need to do anything really, because it simply works everywhere. Now, EO browser as an application, as a front end, is also available on GitHub, again, Leaflet and React, and you can download it and change it to whatever you want. One thing that I forgot to mention on EO browser is that it also supports other here we go, other data sources. So it's not just Sentinel-2, but also Landsat and Sentinel-1 and so on. But we'll come to that later. Now, one thing that we released maybe a week or two ago is one step further with this sharing of the science, because we realized that a lot of the remote sensing science is hidden in the papers and difficult to replicate, and people don't really want to share the methods and so on. So we established our own GitHub repository, where we shared all the we call them custom scripts. So these are basically the configuration of how the one Earth observation product is being created, either visualized or processed. And so they are available on GitHub, those that we created, and also those that some of our users created and shared with us. We really welcome all contributions. We check them so that we see that they work good enough, but we don't do like a scientific curation. We simply share the data from whomever, so that this knowledge can be shared. And so you can go to this address down there, customscripts.sentinelhub.com, and you can browse through all the Earth observation products that we have found and identified, and then you can look each of them and simply copy paste this code to your own environment, and it will work with Sentinel Hub. Now, some of the examples of our users, we have many of them, but unfortunately we can't share a lot of the information because of the non-disclosure agreement. But this allowed us to share amongst some others. Obviously, the agriculture is the most relevant sector, because Sentinel-2 data, which are the most popular data out there, are fine-tuned for vegetation, and it's easiest to create the business on the agriculture. So these are examples from users from Denmark, Australia, South Africa, and two from South Africa in this case. who build their own applications and are serving their own end users, their farmers, whomever, we don't know, based on our web services. And each of them created some of their own functionality, some of their own views, some of additional features to make it more relevant for their users. Another example from Forestry. So this is a Global Forest Watch, an organization which monitors the deforestation in tropical and other regions and tries to take care that there will be some tropical forest remaining in the following years. And they also use our web services to stream Sentinel data to their users. So going back to the features, some other ones that I think are important to mention. So most of the web applications that I was showing you, they use web mapping service because it's easiest to use and easiest to integrate in any environment. But for those who want to post-process the data, to do something else with it, they use web coverage service, where you can define the resolution, for example, so that you always get 10-meter resolution, and you can say, I want the original data, or I want composite, and I want the GOT for JPEG 2000, and I want this or that transformation, and the service makes it ready for you. Another interesting feature is so-called Statistical API, which allows you to get a time series of data. So here you define either, I don't know, a point or an area, and you say, I want to get the data from 1st of January 2017 to now, and you get a nice JSON example, a nice JSON output where you get the average values, minimum, maximum, some standard deviation, and some statistical values, which you can then use for, I don't know, either classification or simply drawing NDVI charts on your application. We take quite a bit of care of what we do with the data so that users can control it however they like it. For example, upsampling and downsampling, you can choose the bicubic or bilinear or nearest neighbor method so that you get either these nicely interpolated features, or you get the original pixels as they were in the image. The one feature that we launched, I think 1 month ago, is a multi-temporal processing, which allows you to process several things. So, for example, a couple of weeks or a couple of months of data, and do the analysis on the pixel basis, and say, in this case, for example, I want to get a maximum NDVI in the last couple of months. This makes it easier to get rid of the clouds or of the haze or some other elements which may corrupt the image. Or you can identify the changes. You can identify changes on the NDVI. So again, there are many things that you can do with it, and it's just to the imagination of our users of how they use it. This is an example of one of our users who is building the mosaics, cloudless mosaics, and each of these images that you see here took maybe a couple of minutes to create, and this couple of minutes means that from the point when you start working on it, when you define the parameters however you like it, so like the colors and the temporal ranges, and then when you have the product. I think that's something that is really, really interesting. Now, we have put quite a lot of effort into supporting OGC services, web mapping service, web coverage service. To be honest, we are not too fond of these standards, but they are very well supported in lots of web applications and desktop applications. And it takes about 6 lines of code to integrate our web service in a typical open layer web application. You copy paste these lines, and you get a global archive of, in this case, Sentinel data through color in your application. Now, to make it easier for users to operate with the API, we have a configuration utility where user can define the layers, so they define how they would like to have them visualized, which time ranges they would like to use, or anything that they really want. All of these features that you see here in the configuration utility can also be controlled with the API. So you don't need to use the configuration utility, but it makes it easier to start, let's say, to define a couple of layers which are then exposed in a get capabilities call, and then the application can use them easily. So when you are creating new layer, you simply select one of the previous templates. So all of those that we share on the custom scripts are available here as well. And you can simply choose one, and then you get a custom script in JavaScript, which if it fits you, you can simply use, or you can change it however you like it. So, I mean, what is most common is that people are not happy with how we define the colors of, for example, NDVI, and then they want to change this to some other visualization because they feel that it suits their needs better. Another feature are the integration tools. So here, if you click in the Open in Playground in the configuration utility, you will be able to preview the configuration, the existing configuration in a Playground application, so similarly as I've shown before, but not on the default configuration, but rather on your own. And another nice thing is if you use this icon for editing, for settings, you enter into the integration tools, where we provided some examples how you can simply integrate your template into Leaflet, Open Layers, and Google Maps. Basically, so the process goes that you define the layers in the configuration utility, you go to Playground, you open this tool, and then you copy paste this a few tens of lines of HTML in your web application, and it's working already. If you're using Google Maps, you need to provide Google Maps API so that it shows the map as well. And basically, you in a couple of minutes, in 5 minutes literally, you have an application with the basic functionality, and then you can spend all the time you have actually creating the added value service for your own users. So, coming toward the end of the presentation, at the moment we support Sentinel-1 GRD, Sentinel-2 globally, Sentinel-3 OLG, so OLG globally as well. We have Landsat 8 globally, and we have Landsat 5, 7, and 8 in the archive, which is limited to wider European region, but goes back to 1984. In this case, I want to mention that USGS is working on bringing the whole Landsat archive to the cloud, and as soon as they do that, we will also provide it, so we'll provide the global access to the Landsat 5 and 7 data as well. Then we have Invisat Mirrors data, we have MODIS, Terra, and Aqua, and we have digital elevation model, so that you can do some terrain-based features. We also support technically some commercial products such as Planet and Pleiades. However, the business models with the commercial providers are a bit are not as open as the Copernicus, for example. So there, you need to purchase the data up front, and then you have them served through our API so that they get all these features. Now, one important point to make is that we actively take care that the data on our platform is up to date. So that means that you don't need to take care that you will see there is a new Sentinel-2 scene available on Sci-Hub and download it. It will be available to the web service as soon as it's available on Sci-Hub. Usually, we are able to copy the data from Sci-Hub in under 1 hour. So it's really, really fast. So let me conclude this talk here with a nice image created by another user who likes nice natural images. In this case, after a hurricane in Florida, nice waters. So thank you very much. And if you have some questions, we can now enter into this part of the WebEx.
Now we check if there is any questions. So please, in case you have any questions, please send it using the chat to everyone. Meanwhile, maybe I can repeat that this is in the context of partnership, let's say, between ESA Business Applications and synergized Sentinel Hub, to give you 1 year free access to this data, to Earth observation data, the one that Grika mentioned before, using the Sentinel Hub platform. So we have one question that maybe Greka you can answer it, and I can read it. Meanwhile, what about the archive for Sentinel-1 GRD images? Will there be the full archive also available?
So yeah, let me answer that. Sentinel-1 GRD images is already available. So we make use of the IPT Interactive Platform Testbed in Poland cloud, and where the data are available, and you can access them through Sentinel Hub already now.
Thanks. So, other question is what scripting languages are supported? Are GDAL APIs included? Greka, as well, this is for you.
So no, at the moment we only support JavaScript, and we implemented some internal libraries and functions that one can use. But if you want to use some external libraries like GDAL or Python or I don't know CV, then you need to make use of the web coverage service functionality and integrate these data on your own site, on your own server, and then post-process them further on.
So, can you detail the requirements? Sorry, there was a new question and disappeared. Can you detail the requirements to be awarded 1 year access? So, if I'm not wrong, it's simply to fill the form in our ESA Business Applications website, and once you have filled it, I think the grant will be given on a first come, first served, and we have, it's correct, Greka, correct me if I'm wrong?
Yeah, somebody, it is Beatrice Barretti. I'm also working the business application here in ESA. I can comment on that. So already on our website, you can find a link on the Sentinel Hub initiative and this agreement that we are having with them. So you have just to fill in a form where we ask basic information, your details, and then we want to have an idea about the sector in which you are going to use the data and what is your vision, what you are going to intend to build with this data. Once that we receive this information, if we think it's eligible within our program, then we will give you a voucher code that you can use to access directly the data from the Sentinel Hub website.
So maybe it's worth also adding that once you have tested the feasibility of your idea with during this year, for example, then you can get in touch once again with ESA Business Application to discuss future different funding opportunities.
But maybe, I mean, at any stage, once that you gain enough confidence, let's say, with the results that you get with the data, we encourage to get in touch with us and to develop even further the initial idea that you have. On the chart now, you see the link to the initiative, so please take a look at that, and in case you have any questions, get back to us. There is a question about the pricing of the data after this initiative. And this is, I mean, the pricing, Grega, it's part of the policy that Sentinel Hub is putting in place. So if you want to have more information on the pricing, I would say that you should contact Grega.
So let me maybe comment on both issues. I think that this initiative was really focused to creating a new ideas on the Earth observation data that, and we wanted to make it easier for everyone to work on the ideas instead of just hassling with the basic data. Anyway, anyone can get a 1 month trial access to our service, so you can do this even before applying to the for this initiative. You can just go to our website and ask for a trial account, and you will get it, and you can test it, and you see whether it fits. What we realized is that for some people, they need longer time to create a business. So this was mostly focused to startups, but it's not limited in any way. It's focused to creating new ideas. So the point is you try the service and you see that it might fit, and then you ask for this 1 year access so that you can really create a business, you can test it. And then after 1 year, so we have a publicly available pricing plans which I copy pasted here. Our goal is to make these services really affordable so that it's a no-brainer. But as it was mentioned, there are possibilities with ESA to even get some further funding for that. And also there is a possibility with our own service to, instead of going for the payments, to go for some royalty sharing or something like that. So we are very open to that, to support the new ideas being built and being used by end users.
Yeah, thank you, Greg, really for this clarification. I would like to emphasize this concept. We are here to support your idea, to support your business. So that's a first step to collaboration, but in case, whenever you see that there is an added value in using this data, and I'm sure there is for you, please do get in touch with us, because we are here to support you even further.
There is another question, again, I think for Grega. What's the maximum size of data one can download to one's local servers?
So, at the moment, one request can be up to 5,000 by 5,000 pixels. So that means if you are downloading Sentinel-2 data, it would be 50 by 50 kilometers, so what, 2,500 square kilometers. Now, but I would here use this opportunity to kind of try to suggest that you don't work with mass downloading of the data, because this doesn't scale well. I mean, it's not about our services, but when you download the data, then you need to store them somewhere. So try to make your applications run in interactive manner, meaning that you ask for the data at the area that user is asking, is needing it, and then you process it on the fly. Because then you make the data really light, the idea lightweight in terms of the cost. But as mentioned, you can download with one request 5,000 by 5,000 pixels. But if you need larger area, you can simply create a script and you split the area into these tiles, and then you download them one by one. And let me answer another question which I've seen, a related one, about the maximum resolution of the image. So the maximum resolution of the image is simply limited to the resolution of the data source. In case of Sentinel-2 data, you have the red, green, blue, and near infrared in 10-meter resolution. Sentinel-1 radar data are 20 by 20 meters usually. Sentinel-3 is lower resolution. Landsat is 15 and 30 meters. So through the web services, you can get the data with the exactly same resolution as the data provider is actually offering it.
And I think, Greg, you can also then give a similar answer for another question, which is the refresh rate of the maps. Again, this is a similar response. It is based on the refresh rate of the data provider. So Sentinel-2 at the moment is refreshed in Europe and Africa every 5 days. But according to the news, recent news, this should go to every 5 days globally in December. At the moment, outside of Europe and Africa, Sentinel-1 is every 10 days. And as soon as the Sentinel-2 delivers the image, which is processed through the ground segment of the European Space Agency, we then ingest it into our platform, and it's available through the web services. In Landsat 8, it is every 16 days. Sentinel-3 is at the moment every 2 days, I think. So again, as often as the satellite provider distributes the images, we make them available through the platform.
And are Sentinel-2 images available with atmospheric correction?
We make available data which is distributed by ESA in general. So that means that from March 2017, Europe Europe area is atmospherically corrected and available with Sentinel and available through our web services. At the moment, there is no possibility yet to get the properly corrected level 2A data outside of Europe for free. That we do offer some on-demand processing. This comes with a bit of additional cost. However, what we do offer is also some statistical method of atmospheric correction, which runs globally, and it is not as precise as Sentinel, but it is quite a good approximation.
Okay, there is another question again for you, more on the, I will say, commercial satellite. So, is there one satellite available with 1 meter or less per pixel of resolution?
So, as I have mentioned, the basic data offering to our web services are the open data, meaning the data that are not commercial. However, we do support Pleiades and Spot in this case, which are both, no, Pleiades is under 1 meter, Spot is I think 1.5 meter. This comes with additional cost because you need to purchase data from the provider. Here I would also refer you to European Space Agency, which does offer opportunities to get this data through them for business initiatives. So this is possible to do as well, and then you could get them through the web services.
What about pre-processing of Sentinel-1 images?
So this is, I mean, this probably you are referring to co-registration of FLC data. This is at the moment not yet supported. So for the GRT data, what we do is we do the auto rectification. This is not done with the pre-processing, but it's rather done on the fly. So it's done, the auto rectification is done, but the rest is not possible at the moment.
Okay, let's wait if there is any other question coming. Okay, if there isn't any other question, I would, well, first of all, thank you for attending the webinar, and remind you that the information of this partnership is in the ESA Business Applications website, as well as also the information how to apply for this opportunity. And in the same website, you can find also further information on how to get in the future, as soon as you realize the feasibility of your idea, to get further support from ESA, and in particular other funding opportunities like these feasibility studies or demonstration projects. So I think this concludes everything, and thanks again to the participant, and great thank also to Greka, and that's it. You have our contacts in the slides, in the website, and thanks again.